A vertical shaft is held in long bearings and carries a disc at its middle. The eccentricity of gravity of the disc from the center of the rotor is 0.3 mm. If deflection due to additional load is 19 mm and critical speed of shaft is 773 rpm, then the range of speed over which it is unsafe to run the shaft in rpm is option E. Options are 25, 75, 125 and 225 rpm. So first write down here the given data, that is eccentricity is given by 0.3 mm and deflection y is equal to 1.9 mm and critical speed of the shaft is given by 773 rpm. So from the deflection equation we can write it as y is equal plus or minus e by omega c by omega whole square minus 1, and we can write it as plus or minus y by e is equal to 1 by nc by n whole square minus 1, because here omega is proportional to n. So and by substituting the values y and e, it is 1 by 1.9 by 0.3 plus or minus is equal to 1 by nc by n whole square minus 1, and which is equal to nc by n whole square is equal to 1 plus or minus 0.16. So we have two values for nc by n whole square. Here one is 1.16 and another one is 0.84. So by already we know the critical speed of the shaft, that is 773 rpm. From that we get two values here, that is n1 is equal 773 by root of 1.16, which is equal to 718 rpm, and n2 is equal, so 773 by root of 0.84, which is equal to 843 rpm. This is the range of speed over which it is unsafe to run, the shaft is unsafe to run. So the range is given by 843 minus 718, which is equal to 125 rpm, and in the options the correct option is C. A simply supported beam of square cross section 5 mm into 5 mm and length 1 meter carrying a mass of 2.3 kg at the middle is found to have a natural frequency of transverse vibration of 30 radians per second. Determine the Young's modulus of the beam, and the options are 1.02 gigapascal, 2.07 gigapascal, 2.9 gigapascal and 0.8 gigapascal. First, let us write the given data of the problem, that is the mass carrying by the beam, that is equal to 2.3 kg, and length of the beam, that is equal to 1 meter, and the cross sectional area of the beam, that is 5 into 5, which is equal to 25 mm square, and the natural frequency of the beam is given by 30 radians per second. So here we will have to find out Young's modulus of the material of the beam. So here, by neglecting the self weight of the beam, the natural frequency of transverse vibration of the beam can be expressed as omega n is equal root of k by m, where k is the stiffness of the beam and that is given by load per unit deflection, and which is equal to load per unit deflection, that is delta. Here where delta is the deflection of the beam for the simply supported beam which is carrying a load at the middle of the beam is given by delta is equal WLQ by 192 EI, where here I is area moment of inertia, that is I is equal to d power of 4 by 12 and which is equal to 0.5208 into 10 power of minus 10 meter power of 4. Okay, here from the equation omega n, that is natural frequency. Okay, natural frequency omega n square is equal k by m, and which is equal to 192 ei by ml cube. Okay, from the formula k is equal to w by delta. So here we can get the Young's modulus of velocity, that is E, and by substitution of all values we can get here E is equal to 2.07 gigapascal. So this is the answer, and the option is here the B.